awesome. Thank you very much. I am super happy to be here. I do. I'm from Denver, Colorado, so it's pretty awesome. I'm able to come to the Seattle meetup, even virtually. I do plan to come up there for a conference, one of the first in-person conference since all of this started. It'll be the Linux Open Source Summit conference up there in Seattle. So I'll actually be up there physically. Maybe I can say hi to a few of you folks if you show up. Anyway, happy to be here presenting this session on DevOps that matters, demystifying CI/CD and build pipelines. This talk is really, it was meant to be pretty informal. Given it a couple of times now in a couple of different venues. It's less technical from a code perspective, meaning it's not a tutorial on how to implement specific DevOps tools, but instead it will be just more thought-provoking around your current development and deployment processes. And hopefully, my goal is that you'll be able to take some of these suggestions back to your team, and it will help you be a little more efficient or improve the quality of your application or service. So that said, a little bit about my background. I am a developer. Primarily, I was mostly worked in server-side Java code, but my experience is polyglot, all sorts, all kinds, many different languages. At one point in my career, I worked for a service company, so we pretty much did, whatever software project came in, that's what we worked on. So I did end up on a Java server-side project for probably most of the second half of my career, but lots of experience in other areas as well. Although I do love engineering and development, and in some ways I miss it, I'm trying to get more involved in the open source community at this point. But I started taking an interest in speaking at events, and on top of a full-time job as a developer and then also trying to put together talks and traveling for speaking, that wasn't working out for me so well. That was a lot of time out of my day. So I decided to start looking for a place to be where I could do this full-time. And that is where I came across JFrog and got the opportunity to become part of their developer relations team, which just made sense for me at the time. Prior to that, I've had 20 years of experience in engineering. This picture, I just want to mention, is from Edinburgh, Scotland. And I'm mentioning it just because back when we could travel places, this was one of the places I went for an unconference. I really like unconferences. And for those of you who don't know what that is, it is a less formal conference. Instead of having a speaker in front of you and a whole crowd, sitting and listening, you actually have basically a circle conversation, smaller group. Not one person is presenting, maybe one person could be leading the conversation, but it isn't actual conversation. And that is where I started getting interested in speaking. I started leading some of these circles, and it was really interesting to get input from other developers in that way. So JAlba in Edinburgh, Scotland was one of these unconferences that I attended. Most of my talks, because of my development background, means that by default, I approach things from the development perspective. I genuinely want to soothe those development and operation woes. And a lot of that just comes from a lot of experience over the years on several different development teams, both successful and struggling projects. So turns out all of that works really well with JFrog values. So this is where I am today. I'll skip over this quickly. Last chance, get your phone out, take your picture of this QR code or whatever to enter our raffle. I'll have it on the Q&A page later too, if you need to grab it again. All right, why should a developer care about DevOps? I was on an Ask Me Anything session recently in one of our virtual conferences, and this question came up. And the answer for me involves a lot of my personal experience of moving to a DevOps team after years of being in that developer silo. It was a new world for me to consider different deployment environments and how code was actually running in production. I had to start caring a lot more about memory, other resource requirements, load on the service. For example, for web services, if my code wasn't efficient, could become a huge problem. Installation procedures. Also, now I'm involved in actually deploying the software and installing it on production machines. If not production, test environments, other QA environments, that kind of stuff. How to troubleshoot an actively running system without taking it out completely was another challenge that was presented to us as a new DevOps team. I learned that we needed, new ways beyond our local development environment, debug logs to monitor the health and stuff of these applications running out there. I started to care a lot more about observability, not just whether my software was up or down, whether my application was up or down, but whether it was running smoothly. For example, do I have a bunch of Docker containers deployed that are constantly restarting for some reason or another? Whether the service is running efficiently for, if I have a lot of requests coming in at certain times of the day, how are we going to scale that and manage that? Whether our application is being attacked somehow, recognizing behavior and metrics that are irregular or outside of the norm that we need to pay attention to. Recognizing whether we had a bad actor that was taking advantage of a known vulnerability. Things like that were all stuff that I was now exposed to being on a DevOps team. Being a developer on a DevOps team that cares about DevOps really is about knowing how the application is deployed and how its behavior in production is going to, at the end of the line, influence how I make design decisions about my application. So the structure of the code, how the different pieces are put together so that they can be scaled individually. That kind of stuff. Those were all new to me. So a bit overwhelming because it seems like, now I needed to learn a lot more stuff than just my code that I'm working on and how to navigate all of that. So today we'll talk about, I'll give a definition of DevOps, which given this audience, that's going to be pretty easy. I'll describe some of the components. We'll talk a little bit about the IT value stream, and then throughout the talk, I'll give you some stories and suggestions of things to do to improve your processes. So let's jump right in here. I'm going to give you these resources at the beginning of the talk instead of the end. Straight from Wikipedia, the definition of DevOps is a set of practices that combines software development and IT operations. It aims to shorten the system's development lifecycle and provide continuous delivery with high software quality. That is a fairly good definition, and it's basically the idea that some of the walls between a development team and an operation team need to be rethought. And I know that the focus a lot of time is on delivering faster, delivering better quality code, but really, this is about communication. And it does not mean that a developer needs to be an expert in operations or vice versa. On a team, you're still going to have your expertise, but it's more about improving the communication between those different skill sets and managing the expectations and working together toward the same goal. So this, I just put 3 books in here. The DevOps Handbook was actually one that was required reading for us in our new DevOps team environment. And this was on a previous team I was on. And I think this should be required reading for everyone. It's really insightful, has some good methodologies, practices that just make a lot of common sense. The Phoenix Project, that is a book that my manager actually suggested to me at the time. I started reading it. I was expecting to read a technical manual type of book, but this isn't that. It is a novel written as a story, which I tend to soak that in pretty well. So it was pretty creatively done, and just basically about an IT project that is struggling, and all of the problems and all of the solutions that were developed in order to accomplish this particular IT project to get it moving forward. Really, really interesting. There was a sequel that came after. That is the Unicorn Project. A lot of the same, it's written as a novel, and a lot of the same characters you'll recognize from the first book, but it's actually from the developer's perspective. The first book is from more of an executive's perspective. So very, very highly recommended books to read if you haven't already. If you're in the world of DevOps, this just seems like the basics to start with these books. That last book, the DevOps Handbook, that is more of an instructional manual on how to put DevOps principles into practice. And it talks about the 3 ways: the principles of flow, the principles of feedback, and the principles of continual learning and experimentation. It's been a few years since I've read these books, and I think it's time for me to reread them. But I do remember the first time through, there were quite a few aha moments. I definitely empathized with the characters, recognized a lot of the struggles, recognized similarities with projects that I've worked on over the years. Lastly, another term you hear thrown around a lot is DevSecOps. That's just the whole idea of shifting security left, getting security more in the mindset of developers and operations, so that security concerns can be dealt with earlier in the process of your development cycle, rather than at the very end, when it is a lot more expensive to sometimes to take care of those security concerns. All right, this is a slide that I see quite often in the JFrog's corporate deck, and I'm just sharing it with you just because it's a pretty good example of step-by-step the software development lifecycle. And this is really busy. Don't really expect you to be able to read all of the tiny little icons and stuff, but I like it because it does a really good job of highlighting how overwhelming the DevOps environment or world can be when you're presented with all of this stuff that's in the market, all of these tools, all of these frameworks. A lot of learning has to happen in order to understand how all of these fit together. And this space is huge, and it's really easy to get lost in this mix, especially as a developer. This whole process is just an attempt to answer the questions: how do I build everything? How do I test everything? How do I deploy everything? Also, where do dependencies come from? How do I keep everything secure? How do I include automation to help increase efficiency and reduce human error? And as expected, there's quite a few JFrog products there in the middle that handle artifact management and storage, distribution and security scanning on packages. But this setup has strong integrations with a bunch of other components and frameworks out there that you're likely already familiar with and using today. For example, build and dependency managers like Maven and NPM, and continuous integration servers like CircleCI and Jenkins, and then provisioning tools like Chef and Puppet. I was on a panel just recently at DockerCon, actually, and a question came up about the state of DevOps today and what might be coming down the line in the future. And we had an analogy come up. I suggested that DevOps right now, well, first of all, the question was, how many of us would be driving cars today if we had to put them together ourselves? And when you think about it, I certainly wouldn't be. I'm not going to be putting a car together. It certainly is convenient to be able to go to, a lot and buy a car and have it already running, and all I need to do is steer it, put gas in it, do the regular maintenance, and it all just works for me. Well, I think if you were to compare our existing DevOps environment with car manufacturing, we're still really early in that development. And what that comes down to is, like, in our software development lifecycle, we're still putting all of these pieces together ourselves. And there's a ton of levers to pull and a lot of mistakes that can be made. And in fact, for a car, we have a general idea of how to make certain components so that they're easily interchangeable when you go to get your car repaired. In software, we're still in the process of working out what components actually make sense. So we're still pretty early. But we do have a pretty good idea of what we need to get everything up and running. And generally, tools will fall within these core components or categories. This is a simplified list of components from that busy slide that we saw before. We can break pretty much everything down into these core components. And there are dev practices around each of these components that can help achieve your goals. Before we go any further, before you jump in and just start implementing a bunch of new processes, get together as a team and determine what your values are. What are your goals? Every project is different. There is usually a driving factor that will help you to figure out what to prioritize. And this is where communication between teams comes into play. If your team is prioritizing something completely different than another team, and by another team, I mean maybe product development or marketing, you're undoubtedly going to experience friction and frustration. So the best self-help guidance out there that I've heard recently, and I can't remember where I've heard this, it's probably from some like financial freedom book or something, but it came up again just in a random Uber ride I was taking from the airport. And this guy, he suggested, you need to figure out what success looks like for you. And this definitely applies to development DevOps teams as well. Define what success looks like for your project. And talk about, what is good enough for your team? What do you need to prioritize that will move you further down the road so that you can accomplish what you're looking for? This photo is of my car. This is my actual car that I have sitting in my garage right now. I just used it here as an analogy of what I mean. This car is pretty old. I think it's 2005 car. And I got in a little bit of a accident. No one was hurt or anything. It was just in a parking lot, but someone hit the side of my car. Well, I'm not about to pay what it cost to, I just have liability on this thing. And I didn't want to mess with insurance and stuff. So I didn't want to go get it fixed. It just didn't make sense, right? This car is enough for me. It's reliable enough. It's economical. It's good enough for me. So I went on Amazon, bought a magnetic Band-Aid, and that's what I used. And that cost me about 12 bucks. So definitely a better choice than spending all of the money to get this thing fixed. I hate to say that a lot of development projects are like that, but there are some projects that are like that out there. And it really, behooves you to be thoughtful about where you put your money and where you put your time and whether it's actually worth it. All right. In a DevOps world, observability of your system is going to become extremely important. And I put this slide in here just to remind me to tell you an interesting story. This is a real life story about a disconnect on my team regarding a specific business value. This goes along the lines with communication and making sure that you understand what your goals and what your values are. So most developers have seen a line like this in the code base before. It's just a simple log line, just indicating that the process has made it to this particular function. And I was working on an efficiency issue with a particular application, a service that was running in the cloud. And I implemented a pretty clever fix. I was pretty proud of myself. I thought, I did a good job. It involved, reorganizing some of the code. And it also involved changing this log statement because it was no longer applicable, just for the simple reason that the function was no longer named transform media, and it just didn't make sense anymore. Well, unbeknownst to me, that little change made a huge fuss. And the only reason I found out about it was because at the time I worked in an open space environment, and all the developers were on one floor, and we had product and management and some marketing teams up on another floor. Well, we had the better coffee on our floor. So oftentimes those folks would come down to our floor to get coffee, and they would talk. And while they would talk, I'd listen to them. And I started hearing talk about this particular service. And I was interested because it was the service I had just worked on and worked on deploying and was proud of, right? Well, the problem was the service wasn't getting used anymore, according to product. And so decided they were going to deprioritize all work on the service and possibly just remove the service altogether. Well, I got really interested, so I got involved in that conversation. And it turns out that there was a Splunk dashboard that was counting every time a process hit this log statement. Well, the log statement wasn't there anymore. So to them, they just thought the service wasn't being used anymore. Now, what would have happened if I just didn't happen to overhear that conversation? We had different goals in mind. I was working toward efficiency on this particular service when, in reality, the business side was they just cared whether it was being used. And that's what they were measuring. And when that measurement went down to 0, they decided they were going to hack the project. So that's that's an interesting example of what I mean by making sure that your communication between your teams is going well. So if you get anything out of this talk, eliminate those types of silos, and not just between members of a team, but between teams even. If everyone is pulling in different directions, you're going to end up stepping on each other, much like what happened in my log story. All right, and you're going to find that a lot of focus is on the end result, your service or application that's running in production right now. And something you realize quickly as you move along in your career is that end result, lo and behold, it depends a lot on everything that happens before. So think about your software development lifecycle as its own product. Consider the processes that you take to get your product to production. Find the waste, find what is slowing everyone down. And part of this is determining your priorities. For your situation, is shortening the time between releases the top priority, or is there a need to focus on quality or security? And something the DevOps Handbook points out is that in the physical manufacturing industry, it's easy to see bottlenecks. In technology, it takes a little more effort. You need to implement methods of making the work more visible. And the best example of this is the use of Kanban or sprint boards to make our activities more visible to the rest of the company. Solutions like this will help the team stay organized and aware of what team members are up to, but sometimes we forget that these are actually meant to help with communication between teams as well. Keeping this information limited to just your internal team members defeats half the purpose of having these boards. So keep that in mind as you are adding tasks to your boards and moving them along the life cycle. All right, let's talk pipelines. It's a popular term in DevOps, but pipeline itself is not a magical word. Everyone has a pipeline. All software has a pipeline, whether it's manual, automated, whether it's high tech or low tech. That word is a bit overused. Many products and services out there have pipelines in the name. JFrog even has our own product called JFrog Pipelines. Those products usually focus on pipelines. They imply automation, but really a pipeline is just the steps that are required to take your code from development to production. And every member of your DevOps team needs to be familiar with your pipeline. If not, stop right now, get everyone together and document these steps, because you may see some surprises in there that you didn't realize was going on. Definitely happened with me when I realized the steps that operations was taking to deploy my software. For each of those steps, Look for improvements that you can make. Where can you get the biggest bang for your buck? We talked about making priorities, and as you step through your pipeline, you might adjust those priorities, but having priorities is not enough. Make sure to document your goals and determine what metrics you can use to figure out if you've met them. And start out small with goals that improve some facet of your pipeline by 1%. An example of a bad goal would be deploy faster. Well, there's no numbers around that. There's no measuring that. So you need to start with a baseline. How long does it take you to deploy today? How much improvement would you like to see? A good question to ask to figure out what that measurement should be, what that metric should be, is how do you know when to start focusing on the next priority to get further improvements? This is an excellent time to consider different tools and frameworks as well that promise to help with your flow. But the most important thing that I want to stress is always have a reason for change. Don't just go switching out technologies without having some metrics behind it that prove worthiness. And yes, it's fun to play with new stuff, and there should absolutely be time devoted to that. But implementing new tools across a team needs to have serious thought and consideration behind it, and you need to have buy-in from the team on this as well in order for it to be successful. And one thing I've learned over the years with all of the new promising DevOps frameworks and technologies out there, there is always a cost associated with switching one out for another. We're often guilty of seeing the pros right away, and then only after the upheaval of change do we see the cons. So one example of that was our team. There was an order that came down from on high to switch out CI servers, continuous integration servers, across the board for everyone. That turned into quite a mess for us anyway. Recognizing problems. Sometimes you're so far in it, you don't even know there's anything wrong. And this story is about continuous integration. And I had a situation where my team, we were all, doing the normal thing. We're all checking our code into a common source code repository. But the problem is that there was no intermediate step to make sure that the code was good before it got put into the master, the main line of the code. So what would happen is you'd come in the morning and you would have to make sure to check your email first before you check out the latest code. You need to check your email and make sure that the build wasn't broken. Because if you go ahead and bring down the code, now you can't even build locally or anything because you have to wait until that build gets fixed. We call those donut days. When you figured out who broke the build, they're responsible to bring in donuts for everyone the next day. Now that, depending on how much you value eating donuts, you might not see that as a problem at all, but there is definitely a better way to do things. And part of moving to a DevOps team, we went to a system of doing pull requests. That was really valuable. Being able to put your code out there, have it run through all the tests before it gets merged into the main line code branch. That was just invaluable and saved us all a lot of time. Really take a look at your continuous integration. That's most likely a place where you will see some improvements if you're not already doing that process. Know your build. And I'll go a little quicker here. I know we don't have much time left, but a build server is going to do the heavy lifting, but there's a lot more that you can do on the development side, putting that project together. There was one time I had a multi-module Java project, and this was pretty early on in my career, and I didn't understand how it was all put together. So every single change I made, I would just do a Maven clean and rebuild the whole thing. Well, that's ridiculous. That was wasting a lot of time. And if I had just taken a few moments or maybe, had a mentor explain to me how that build was working as I was onboarded onto the team, that would have saved a tremendous amount of time and effort on my part, just understanding how all those pieces and parts are put together. So making sure that your onboarding includes those types of lessons for people as they come into the team is super important. Another one is about Docker files. Like now, once you start building these images and putting them out there, realizing what is actually happening when that Docker container or that image is being built. I had an instance where every time we build a new image, it was actually, reaching out, pulling in a script and running the script. That's pretty dangerous if you think about it. Like, where is this stuff actually coming from? So understanding where your artifacts come from, super important. All right, test and QA environments. Do not skimp on these. I've been on teams before where this has been a very, very low priority, and it just costs a lot of time. Not being able to reproduce bugs and not being able to test your code really in an environment that closely resembles production is super important. We don't have any excuse anymore today. I know for a lot of the Java projects I worked on, we have test containers that we can use. So no longer am I relying on an in-memory database, for example. I can actually use the version of database that is running in production to make sure there aren't any weird SQL problems going on there in the code. So making that a priority, making sure that you can catch, sneaky API issues or other version problems and stuff. Having a decent QA environment is just a requirement for any project. All right, lastly, how do you deploy? I was in a situation once where when we were walking through the whole life cycle and how deployment happened, I realized that there were all these little scripts out there on individual machines, operations machines, that was doing the work of deploying these projects. Well, the problem was they weren't put in source control of any kind. So you didn't really know from one version to the next how it was actually deployed or what changed in the configuration. So good luck if you needed to roll something back, because once you changed it all up manually and deployed, and if it didn't work, heaven forbid that actually happens sometimes, it was really difficult to roll back to get it, how it was before, because we didn't have the old files. So moving all of that stuff into its own source control and keeping track of configuration that way was really invaluable. All right, so just in summary, that was all just kind of a high level overview of things that you might want to pay attention to. These are the things I pulled out from my experience. So understand your project's business value and goals, eliminate those silos, get rid of those communication problems. That might mean assigning a liaison, your team lead or manager, somebody to talk to other teams. Document your flow, your pipeline. Get together at a whiteboard and document every single step that you take. This will be really invaluable for onboarding for people moving on and off your project. And you may find some surprises that need fixing. Prioritize and improve 1%. Always a good thing to do. Make your work and your metrics for success visible. Set yourself up for success. Measure a baseline before you make changes and set up those realistic expectations for the outcome. And this will also help you with prioritization. If you realize during that exercise that a desired change turns out to have an undesirable cost to benefit ratio that doesn't match up with your project goals. 5, master your CI/CD, your source control management, your testing, your artifact management, and your deployment. Know the details of your build, where your artifacts are coming from, and how things are tested and deployed. And then finally, automate where it makes sense. Don't just automate for automation's sake. Automate what will give you the most bang for your buck. Obviously, this is going to depend on your priorities for your project and the definition of success for your project, but you might find that automating just a portion of your workflow is all that's necessary to meet or exceed your goals. All right.